Hello and welcome. This is the first episode in the Finding Your Wavelength in Wireless blog and video training series. This series is aimed at anyone interested in the world of wireless networking. We hope to help the new guy as well as review for dedicated professionals. This episode will be one of many educational building blocks. This episode focuses on three topics. How is Wi-Fi used in both a home and enterprise environment? Who is in charge of Wi-Fi? And finally, Wi-Fi standards and amendments and what they mean. According to Webster's Dictionary, Wi-Fi is wireless networking technology that uses radio waves to provide wireless high-speed internet and network connections. There is, however, much more to Wi-Fi than just shooting out radio waves all over the place. Where is Wi-Fi used? Wi-Fi is used everywhere. Of course, you know about the network in your home. Most all businesses employ a wireless network. It's all but required in an educational environment. You also have outdoor stadium deployments that are responsible for thousands of users. There are even mobile Wi-Fi deployments such as planes and trains. I bet we've all used a public hotspot once or twice. I know I'm missing some examples, but there really is no limit to where you can deploy a wireless network. The use of wireless technologies has advantages in all areas of residential and commercial endeavors. It used to be that in your home, Wi-Fi was probably used mostly for browsing and streaming music or videos. Now it's possible the wireless network in your home has a much larger job. You've always had your computer on the network, but now you have your tablet, your phone, security system, thermostat, even some refrigerators require a connection. The same is true for the commercial application of Wi-Fi. Sure, it's also used for browsing, but also applications like networked cash registers, phone systems, barcode scanners, and location tracking, to name a few. So there's more to Wi-Fi than just an outlet to tell the social media world you're having a pumpkin spice latte. Even Wi-Fi has rules to adhere to, and like all other rules, they come from certain groups of people focused on a topic. There is actually a government side with actual laws and restrictions. These sets of rules come from the FCC if you're in the United States. The FCC has a designated channel available for use in the 5 GHz and 2.4 GHz frequencies. The reason for the set amount of spectrum use is that Wi-Fi is not the only RF-based communication system. For instance, Wi-Fi can interfere with radar if on the right channel. This means all devices manufactured for use in the United States has to comply with the laws concerning frequency and transmit power. Other countries have other options available for spectrum use. Japan, for example, has channels 1 through 14, while the US only has 1 through 11. The IEEE, or Institute of Electrical and Electronics Engineers, was founded on January 1st, 1963, when the AIEE and the IRE merged to form the IEEE. The IEEE is the world's largest professional association dedicated to advancing technological innovation. IEEE's core purpose is to foster technological innovation and excellence for the benefit of humanity. The IEEE is responsible for the 802.11 networking standards and amendments. More on that in a minute. The Wi-Fi Alliance is an organization consisting of about 600 member companies that are driving new technologies and applications and certifying thousands of Wi-Fi products each year. Founded in 1999 and better known for the Wi-Fi Certified Seal, the Wi-Fi Alliance ensures interoperability and assurance the device can perform as claimed. An 802.11 standard is a set of media access control and physical layer specifications for implementing wireless local area network computer communication. These standards are created by the IEEE. The IEEE has a committee devoted to LAN standards. This is the IEEE 802 work group. Wi-Fi actually had an early start, and the origins date back to 1985 when the FCC released the ISM band. There have been many amendments to the 802.11 standard, and here's a quick look at some of them. 802.11. This is the original version of Wi-Fi. This version was published in 1997. This standard operates in the 2.4 GHz ISM band and used frequency hopping spread spectrum and also direct sequence spread spectrum modulation and operated at a data rate of 1 or 2 megabits per second. 802.11b. Released in 1999, this amendment introduced high-rate direct sequence spread spectrum, which used a new encoding technique and enabled rates up to 11 megabits per second. 802.11b operates in the 2.4 GHz ISM band. Direct sequence spread spectrum and high-rate direct sequence spread spectrum were the modulation technologies used, and the data rates jumped to a maximum of 11 megabits per second. 802.11b is backwards compatible with 802.11. 802.11a. Released in 1999, this amendment introduced 5 GHz technologies and orthogonal frequency division multiplexing. 802.11a operates in the 5 GHz band. This was important due to the amount of available channels and also addressed future concern about oversaturation of the 2.4 GHz band. OFDM technologies enabled 802.11a devices to achieve data rates up to 54 megabits per second. 802.11g was introduced in 2003. It's similar to the amendments 802.11 and 802.11b in the fact that it operates in the 2.4 GHz band. This means it's backward compatible with legacy devices. 802.11g introduced extended rate physical orthogonal frequency division multiplexing and boosted rates to 54 megabits per second. 802.11n was finally published in 2009. This amendment was evolutionary in the fact that it operated in both 2.4 and 5 GHz bands. 802.11n ushered in several new technologies such as MIMO and high-throughput orthogonal frequency division multiplexing. Once again, the data rates made a jump. The support for MIMO allowed rates as high as 600 megabits per second. 802.11ac is the current standard. It is finalized in 2013, and like other amendments, it brings new technology to the table. 802.11ac introduced support for 8 spatial streams, multi-user MIMO, and beamforming. 802.11ac operates in the 5 GHz band with the additional support for 8 spatial streams. It can achieve data rates over 6 gigabits per second. This is a theoretical rate. In review, you should be familiar with the various uses for Wi-Fi, and also how do they apply to different scenarios, who's in charge of Wi-Fi, and the different aspects of it. IEEE standards, different technologies used with each amendment. This is all for the first episode of Finding Your Wavelength in Wireless.